Hi everyone, Mike here. In the last couple of videos I showed you how to put together an ESP8266 with a 7-segment display and make a clock that could get the time from the internet with switches for daylight savings and AM/PM indication versus 24-hour. This time we're going to add some sensors and make a thermometer instead using the same hardware. We're going to use the DS18B20. This is one of my personal favorites. Comes in a lot of styles, it's got great accuracy, it's very easy to use. You can see 3 different flavors here. The first one is board mounted TO92. The second one is a waterproof on a cable. And the third is designed for fitting into 1/2-inch piping. It's got a stainless steel mount and the cables. We're going to use the TO92 package. Pin 1 connects to ground, pin 3 connects to the 5-volt supply, and pin 2 connects to one of the data pins. We're going to use pin D5. In this case, we're also going to use a 4.7K resistor to provide power from the 5-volt rail to pin 2. There is a micropower mode, although we're not going to use that. In the schematic, I also add a second LED, which is attached to pin D4, and this will allow us to have 2 LEDs, one for over temperature alarm and one for under temperature alarm. This fritzing diagram shows how to add the parts to the board. I put the second LED next to the first and the temperature sensor in between. It's not shown terribly clearly here, but there's a row of pins behind this sensor to add a second one in parallel. You can do that with some of these devices because you can parallel them up and the software will notice the ID within the chip and treat them separately. This is what my board looked like after I put it together. Once again, very similar to the fritzing diagram. Once again, we're going to need another software library. Open the Arduino interface, go to Tools, Manage Libraries, and type in Dallas. Select the Dallas Temperature library and install. This tells you that it also needs some dependencies, so install all. Once installed, close that window. And go to Examples, scroll down until you find Dallas Temperature. We're going to select Simple. This is just to test our hardware. Once the file is open, we need to change the pin to 14. This is the Arduino reference pin, not the pin on the Wemos board. We're also going to change the serial baud rate to 115,200. Add a delay of 1 second in the loop, and then upload the sketch to test the hardware. Go to Tools, open a serial monitor. You should see the temperatures being printed out in Celsius, showing that all the hardware is working correctly. If you don't, go back and check the hardware connections. Make sure you've got the device connected to the correct pins and fitted in the right orientation. Also check the data rate on the serial port. Once everything is working, we need to save this file. So let's save it as our own thing and call it Thermo1. Next, we need to add the display. The first thing we're going to do actually is resave the file as Thermo2. Much of the code that I'm going to bring in here is common to the clock software that I showed earlier. I'll introduce it a piece at a time. First, we need an include statement for the display driver. Then, I like to introduce the constants that define the file on the serial port so that you can identify what code is running on your hardware. Next, I like to put in these definitions. This describes the pins on the board compared to the ports on the Arduino. Having defined the pins, we're now going to use them. We'll change the comment about port 2 on the Arduino and we'll replace it with pin 5, port 14 on our hardware. We'll replace 14 with the constant D5 pin. We're going to add a switch variable on D6 pin. This will help us with the Fahrenheit Celsius selection. Next, we're going to introduce a Boolean variable, units Celsius equals true by default. We're going to add a temperature variable, which is a floating point value. Next, we have to provide the address of the 7-segment display. By default, this is 70, but due to the jumpers on the back, this can range from 70 to 77. Moving down into the setup function, we're going to add a brief delay and print a few lines on the serial port. Firstly, we're going to print a blank line to clear things out, and then we're going to print the information defined at the top of the file so that we can easily identify what code is running. Next, we're going to replace the default comment from the simple example with our own custom message. You can put in what you like. We're going to define one of the pins as an input pull-up for switch 1, the Fahrenheit Celsius. Then we need the code to get the display going. In the loop, we're going to delete most of the basic code. The first thing we're going to do in the loop is read the state of the switch. If it's true, units Celsius will be true. If the switch is not true, then units Celsius will be false, which indicates Fahrenheit. Next, we're going to request the temperature from the sensors. And if the units are Celsius, we're going to get the temperature by C, and then print on the serial port the temperature in Celsius. Else, if it's not, we'll get the temperature by F, Fahrenheit, and print Fahrenheit. We're also going to print the temperature to the 7-segment display with 1 decimal point. The delay of 1000 milliseconds, or 1 second, will give us a reasonable refresh rate. Save the code, upload it, and open the serial monitor. Once the code has finished loading, you should start seeing the output on the serial port. If you change the setting of the switch, it goes from Celsius to Fahrenheit. The final step now is to add some alarms. The DS18B20 actually has internal hardware for alarms, and you can find this in the example, but we're not going to do that now. Start off by saving the code under a new file name. I always recommend this when we're making code changes so that we can go back and see what we had before. We're going to define some more connections to the pins. Firstly, a red LED which will be on the pin D4. Next, we are going to add a second switch and a green LED on pin D8. Add a Boolean variable to control the LED on-off polarity. Then add 2 more floating point variables, high temp alarm and low temp alarm, and set some arbitrary values in Celsius. Coming down into the setup area, we need to define the pins that we're going to use the red and green LEDs and set them as outputs. Then we're going to write to both those pins and set the LEDs off initially. We're going to serial print the high temperature alarm and low temperature alarm settings to remind us what they are when we turn on the code. And then move down into the loop. After the request temperatures, we're going to get the temperature in Celsius and then test if the temperature is greater than the high temp alarm. If it is, we're going to turn the red LED on and print to the serial port the high temp alarm is active. If the alarm is not triggered, we're going to turn the red LED off. We're also going to check if the temperature is less than the low temp alarm. If it is, we turn the green LED on and send a message to the serial port that the low alarm has triggered. Otherwise, we turn the green LED off. If the units are set to Celsius, we already have the value of temperature, so I've commented out this second measurement. Otherwise, if they're Fahrenheit, we need to get the temperature in a Fahrenheit setting by getting temp F. That's it for the changes. So save the code, open a serial monitor, and upload the sketch. Once the sketch is uploaded, you'll see the information come through the serial port and a readout of the temperature. If I touch the sensor to raise the temperature, you'll see that as it goes up and gets past 29.5, the alarm triggers, the message comes through, and the red LED comes on. Release the sensor, the temperature goes back down, the alarm stops, the LED goes off. That completes the changes for this video. We repurposed our clock hardware to add a temperature sensor and changed the code to make a thermometer with over and under temperature alarm indication. If you found this interesting, please consider subscribing. In the next video, I will show you how to change this simple thermometer into a temperature controller. See you then.